Welcome, developers. My name is Tom Manshreck. I am a technical writer. I write the Maps API documentation. Probably you get a lot of engineers giving talks. I'm a writer. So I'm here to kind of give you a different perspective. This is more of a tutorial for one of our products, which is the Maps Data API. And you're probably pretty familiar with this right now, but we have a live blog in Wave. So you can use this bit.ly to get on the live Wave and post questions and ask them. Leave this up for a little bit. Just a little bit about myself. I've been at the Maps API team since 2007. I think you've seen a lot of good stuff today. We've launched the Place API, or we will launch it soon. And we've also basically migrated V3 to be the default application. So today I'm going to talk about the Maps Data API. First of all, how many people are familiar with V3? And how many people are using V2 applications? All right, so it's roughly half and half. So what I'm going to be doing today is basically describing how you can use the Maps Data API to do a mashup in V3. Now, what counts as Maps data? I like to think of Maps data in terms of three basic categories of stuff. You can have your own personal data. This is the kind of stuff you're walking around, and you have a favorite coffee shop. You want to peg it down, do it by location. Another one would be a shared model. And a shared model would be like you have a group of friends, you have a bunch of bike paths you want to share in a club or something like that. And then finally, there's the public model. Many of you in business are going to like that because the public model allows you to give your data to your consumers. So basically, the Maps Data API allows you to pretty quickly get an application running that presents your data to your users. So why store in the cloud? I think probably many of you probably use Gmail. I've learned to love Gmail. This is a model for storing geospatial data in the cloud, in the Google Cloud. It is safer. We have redundancy. It's exposed via multiple interfaces. What I'll show you today is a Maps Data API that you manipulate. But anything that you put there will actually show up on maps.google.com in your My Maps directory once you're logged in. And finally, it's accessible from any browser or application or server, meaning that you can provide one application to serve data to people looking at it on a desktop or a mobile device or to another service. And we do use this uses the Google Data Platform, so we do use the open standards of Atom. So what's the Maps Data API? It's an interface to Maps data stored in the Google Cloud, and it's basically a REST API. Which is the Google Data API, which allows you to do basic create, read, update, and deletes. It does these through HTTP requests. So you can think of these things as URLs are actually kind of functions with parameters. And in a kind of neat way, create would be a post. So if you send a post to a URL, what that says is I want to create something. If you send a get, I want to read something. If you send a put, it means I want to update something. And you can also send a delete to delete something. So you can do all those operations in the Maps Data API. Maps Data API works through the concept of feeds. These feeds basically manipulate three different entities in the Maps Data API. We have feeds for maps, which counts for a collection of data. Now, I don't want to confuse you and say that we have a feed that allows you to create what is known as the Google Maps map with the tiles and the paint and all that. A map here would be a collection of geographic data. You might have crime statistics, from Chicago, where I was born. Seems to be a hot topic all the time to have crime statistics being indexed in data. But it's the collection of that data that you put together, which counts as a map. We also have a feed for features, which is an individual feature on that map. So you can manipulate not only the map as a collection of features, but you can manipulate individual features, including the data that you attach to those features. And finally, we allow you to manipulate access control lists. And that will allow you to do your private, shared, public model. And we launched the Maps Data API at I/O last year. But it was purely an HTTP service at the time. We didn't have a lot of features. We have updated it, so I wanted to give you an opportunity to look at those new features. And one of the most important is spatial search. And we also allow attribute search. Spatial search will allow you to search for a bunch of features within a given radius. Or a bounding box, let's say a viewport on a map. An attribute search will allow you to search for your own particular data within that area. So here's an example of what I was talking about with the basic feed. Now you might think, that's URL, I'm going to get some web page. But that's not actually how it works. A post to that feed, which is the top one, this is called the default feed. This is a special feed. This is a feed that basically is just yours. What that means is if I send a post request to this, it's going to create a map. So the initial map can be provided as XML or comma separated values or KML. KML turns out to be the best to manipulate within the Maps Data API. And once you actually create a map here, if you send a post to this, you'll get a map with some URL parameters, and you can actually look at it in My Maps. The second kind is the basic feature feed. So that's actually to manipulate little features. As you see there, instead of maps feeds maps, I'm going to maps feeds features. So it's a very similar URL that you would send. A post to this one would act to create a map. Would act to create a feature in the map. You see here that you have to specify your user ID and your map ID. That means it's per user and it's per map. You can't have features across multiple maps, but you can have a large number of features within any given map. And the features are exposed as KML. So we now support points, line strings, and polygons. We also support authentication options, which is we have authsub and OAuth support. And we provide authorization via access control lists. So this is also a feed. So you can send a feed for your default feed, which is everyone in the world, or you can send a feed for yourself. Now, importantly, the default feed has a default of read, meaning that if you create a map on the Maps Data API, it's not necessarily public. It's called unlisted, which means if someone has that ID, they can actually look at the data. So this allows you to create a map, create a bunch of data, and then share it with someone else without necessarily it being public. But you can also change that to be a completely private application. So you can change the default feed to nothing. And in that case, no one's going to be able to get at your data. And it's, of course, also right for yourself. Now, if you looked at all that, you're like, I got to send these URLs and manipulate this stuff and read this stuff back. No, I didn't like doing that either. So, I mean, URLs are a pain. So what we've done in the Maps Data API is we've provided client libraries. When we initially launched, we only had Java. We only had Python. We launched Java in June. And in December, we launched the JavaScript client library. Now, many of you are going to be creating applications on your own servers. So in that case, you're actually going to want to use Java or Python, probably. But I'm going to be using JavaScript today because I can do it completely within the browser. So here's an example. The first thing you have to do when you use the Maps Data API is load it. And if you're familiar with V3, you're probably familiar with this paradigm of loading the application. So you're loading JavaScript here using the script tag. And I'm loading 2 packages. And this is nice and convenient because this actually loads everything asynchronously. So I'm going to load the gdata package maps, which is the Maps Data API. And I'm also going to load Maps API v3. You see this Google set on load callback. What that basically means is that when both of those packages are ready, call that initialize function. And then here's a simple pattern for using authsub to redirect to Google login. Now, importantly, this is an application that's existing on the internet. Someone opens it up. If you want to be able to use it yourself to enter data, you're going to need to provide some sort of authorization in that application. So this is a good pattern here. It basically checks whether you're logged in, checks the login status. And if you're not, it's going to basically call this Google accounts. It's going to call do login. It's going to go Google accounts user login. That's going to do the three-legged dance with OAuth. It's going to bring you to a page where you log in and identify yourself, and then it's going to ask you whether you actually want to allow this application to edit your data. And then finally, there's a little trick. You got to have an image on your page someplace. Most people do anyway, but it's just important. This actually holds the authorization cookie. So this may trip you up, so just make sure that you put this. I'm going to post all these slides on code.google.com when this is done, so don't worry about taking copious notes. Here's a simple example. I talked about creating a map. That's the default feed. So as you see here, this is JavaScript. This isn't Python or Java. So this is done through callback functions. And we have a map feed URL, which is the default feed. And basically, I call the Google Maps service, and I pass it that map feed, and I also pass it a callback function. So what that's going to do is that's actually going to assemble all these parameters. I'm going to set the title. I'm going to set the summary. And then I'm going to call insert entry. Insert entry is actually doing the HTTP post there. So that will do the whole operation. Once that's done, it'll return, and I will get my map, and it will return an ID. So that's creating a map. You only need to do that once. You don't need to put that in your application. You can just run that once, and now you have a map. You'll have a map ID, which will consist of your map ID and your user ID, and that will allow you to uniquely get the map. So let's create an application with this, and I wanted to give you kind of an application design specification. This is the thing that I create. I like coffee. I drink a lot of coffee. I think I drank 6 cups today, and I had about 3 hours of sleep. So in that case, I want to have a coffee rating application. And so I can go around and have a cup of coffee, basically click and say, hey, I like this coffee. What kind of coffee did I have? What's the name of the place? That kind of thing. So I can look at it later. I want to use the Maps JavaScript API v3. And I also want to use geolocation so I can find out where I am. These are a lot of things that have been talked about today. And I want to have the data populated into the Maps Data API. And finally, I want to be able to implement search. I mean, putting data in is great, but you also want to be able to retrieve that data later on. Generally, that's a good thing to do. So I'm going to show you this application first so you can get an idea. So this is the application here, and I'll just refresh it to make sure I'm not cheating. Oh, wow, now I'll go to Alameda. Didn't do that before. So I can go to San Francisco and geocode that. And what I want to do here is I want to basically click and add a coffee joint. So if I go down to, let's just put a random coffee joint here, I click and it says, you must log in to enter data. So I provide a little login button over there, and this will do that little 3-legged auth dance. So I've actually logged into my account previously, and what you've probably seen this if you're familiar with Google Data. I basically have to grant access to this application. So I'll click on Grant Access. Everything will refresh, and will bring me back to Alameda for some reason, which didn't do today. And I'll just give you an example. So I click. I say, this is going to be OK coffee. And I have options for the type of coffee that I want. You might not be familiar with this last one. It's a big popular coffee in Australia where I'm based. I have not actually figured out the difference between it and a flat white. I mean, between it and a latte. Maybe you know the difference. They both taste the same to me. So it'll allow you to select the coffee. It'll allow you to give it the rating. And then I will add the coffee. Now, I put a temporary marker on there, but it's actually also doing that insert feature. And it's sending that to the Maps Data API. And if I go to my Maps, I will have my little coffee shops around the world. And here you can see an example, if I can get this bigger, of all of these little coffee joints around the world. So you can get an example of this is how it would be exposed in my Maps. All right, so you have an idea of what we want to build. So I'll walk through that building. So the first thing you need to do is set up your map. Now, if you've used v3 before, a lot of this will be very familiar. There are a little bit of some few differences here. You see that I put in a bunch of global variables. The reason I did that was because we're going to be filling this stuff in with callback functions. So these things are not so the JavaScript symbols are not going to be there until that initialize function comes back. So instead, I put these as global variables. I don't actually construct anything. And I put my map ID there just as a convenience so I can use it again and again. So there's that function initialize. That's going to get called when everything's ready. I'm going to create an info window. I'm going to create a geocoder, if you're familiar with the geocoder. And I'm going to create my map. And basically, what I'm going to then do is call the geolocate function. And then I'm going to add an event listener for that map on clicks that will call something called open coffee dialog. So that's a pretty simple initialization. So the geolocate function, which somehow put me in Alameda, probably because there's some weird VLAN here. I used W3C geolocation here because it's the best standard. You can also use Google Gears. There's Latitude API people are talking about too. So there are a variety of different options that you can use for your geolocation. But basically all we're doing is checking whether geolocation exists. And if it does, we're getting the current position. And then we're creating an initial location with that latitude and longitude and centering the map on that location. And if we don't have any geolocation, as you saw, I put there a little fake, which would say it would take me to Moscone. It's always a good idea to have a default. So that click event is what's called an event handler. So I click that event, and what I want to do is open that coffee dialog box, which you saw. So the first thing that I'm going to do is I'm going to populate the location where I clicked. So I get that from the event not that long. And I'm going to create this little HTML form. You see this actually is a form with a table, types of coffee, and the ratings. Don't really need to go into the specifics. And at the end, I actually hide the lat and long as form values. And then I have this on-click save data. And finally, when that's done, I actually just basically set the content of some HTML, set the position, and open it. And what that basically means is that now I've instantiated that info window with that form. And then finally, when I save the data, all I simply do is take out those form values and stuff them in, and then pass it off to another function. So it's pretty simple. So the whole meat there is that I have a map. I want to add features. So how do you add features? Well, of course, Maps Data API can support tens of thousands of features. So you don't want to be loading everything in all at once. Instead, what you're going to do is load in a map and then load in individual features that you pick. So the way you would actually access the feature feed is to get the map feed for your map, get that map entry, and then to get the maps entries feature feed, and then populate a feature entry, and then insert that in. So it's a two-step process by design. So in this add coffee, which is being passed those variables, what I do is I set up my map feed, which is this map URL, which is to that map ID. So that's just me. Oh, excuse me there. And then I will get the map entry with that, get my coffee map, and then pull out the feature feed URL. Now what that means is that what I'm taking that map feed, and I'm getting the URL. Now if I send a post to that map feed, it's that specific map feed, I'm going to end up creating a feature. So then I pass all this stuff off to another function. So I'm doing a little bit of passing around here, but it's a lot clearer that way. So this is the meat of adding the feature. And it's pretty simple. Basically, I just go through each of the things that was passed, and I create a title using text. So I basically create a new feature, which is the google.gdata.maps.feature entry. And I set the title. And here's the interesting part. The interesting part is that I can actually put arbitrary name-value pairs as custom data. So any data that you want to store, you can put in there right now. And I use that using the custom properties of KML. So I will put the coffee, and I will put the rating, and then I will set the actual KML content. Now, since this is a bunch of coffee locations, it's going to be point values. I mean, I could have put polygons or something like that there, but that would be complex. So I'm basically just going to take the latitude and longitude, which I extract from the location, and create a place mark point. Then finally, I'm going to set that KML to the KML string, and I'm going to set that MIME type to the KML MIME type. Once I've done all that, I'll actually call that insert entry. And what that's going to do is send an HTTP post with that information to my map, and it's going to create a feature. So I'll just go over that again, just in case. So if I click here, it populates the HTML form. If I just type something in and I do this, I created that temporarily, but it's sending that off as an asynchronous request. When the info window disappears, is when it's actually created and comes back. Okay, so that's good. I can put coffee joints there, but I mean, the important thing about the data is actually being able to use it. So what I want to do is implement a search. Now, there's various different ways that you can do a search in the Maps Data API. A search is basically a search over features, so it's actually a special type of feature feed. So basically, you use the normal feature feed, pass /snippet, which basically means that I want to get little bits of snippets of information from all of the features that are within a certain area. And you can pass two types of feature parameters. You can search on attributes, which are those arbitrary name-value pairs that I mentioned before, like the coffee type and the rating that I gave. Those are passed within brackets using the map query parameter, the MQ parameter. Example there is MQ is rating 5, for example. I've never had coffee that good. No, wait a minute, New York I did. And then I do spatial searches by either a radius or a bounding box. The bounding box is a pretty convenient one for your viewport. If you just basically want to take your maps viewport and say, like, show me what I'm currently looking at. But I'll do a radius search. And basically, radius requires the Latin long center, and it requires a radius that's expressed in meters. And they have an optional sort by parameter, which returns the results in a specified order. And so we're going to sort by distance. So basically, we're going to return the first results. I don't actually use that because I just populate the stuff on the map. But you could, for example, use that to give someone a preferred location, like the closest store that they're near. So here's an example of doing the search. So I'm going to create a button on my map, and it's basically going to be search, and it's going to give it a radius, 5 miles. So you see that I basically take the feature feed and just add the /snippet signal flag. I'm going to basically assume that I'm searching over the center of the map. So I just basically get the center of the map and give that the address. Now what I do here is I actually extract the lat and the long from that address. And then I will extract the rating and the radius, and I'll multiply by 1609, which is the number of meters in a mile if you live in a place outside the United States. And if I create attribute features, basically I just create an array, so they'll come in brackets, and give it that string. And I could do that for multiple ratings. And then basically there I construct that full URL. And then we'll send that off to the feature feed. Now what I'm going to get back is an array of features. I'm not going to get just one feature. So I create an array, and then I will call another function, show results, passing it that array. So I've gotten back a bunch of features as an array. So I will call show results with those results. What I'm going to do first is create a lat long bounds object. And the reason I'll do that is that basically I'm going to try to center the map on all the places that I've searched. And I'm going to expand the bounds with each feature that I return. I'm also going to clear the markers, which is just a little trick. So I'm going to clear any previously existing markers. And then I'm going to iterate over those features. And for each feature, I'm going to pull out the title. I'm going to get the custom properties and pull out the coffee type and the rating. And then I'm going to get the KML, which in this case is done with get content, get text. And I'm actually going to parse over the KML here, which is a bit of a challenge in JavaScript. But bear with me, I have some surprises for you at the end. And then I'm going to call, I'm basically going to extract the coordinates. Now note here that I actually have to extract and construct the lat long with reverse coordinates. And that's because KML passes longitudes, comma latitudes. The Maps API does the reverse. And then I'm going to create a marker at that coordinate with the title on my map. And then I'm going to attach content to each of those markers in an info window. And I'm going to extend the bounds, and then I'm going to push that marker onto a temporary array. Now that array there is just for convenience. That's so later on I can actually look through the array and clear it out. So if I want to add, when I do another search, I don't want previously existing markers to exist. And then finally, I'll fit the map to the bounds of those features. And this is the example of attaching the content, the HTML content. So I'm going to add a listener for the click event on that marker. Remember, this is a listener on the marker, not the map. And I'm going to set the content to that title and the coffee type and the rating. And I'm going to position the info window where the marker is, and I'm going to open it on the map. And here's an example of just iterating over the clear markers when I want to do that. So I'll just show that again so you can get a good idea of how it works. So I've done here, what I'm going to do is, I've actually lived out here for 6 years, and I used to go to Berkeley. So I will jump over to Berkeley, and I will search for 5 miles over Berkeley. You see that I retrieved 4 features. I auto-centered the map. And if I go and I click on each individual feature, I have my little foo coffee shop. Coca-Cola is an actual real coffee shop. And my favorite would be Cafe Strada. So you have an idea here that I'm basically, if you've worked with KML before, you realize that it doesn't have data, extended data attached to it that can display like this. This is an example of the versatility of the Maps data APIs, that I can pull out arbitrary data and populate it on a map. Okay, so I mean, I've shown you pretty quickly how you can get a working application done. It's a personal application. It's not necessarily a very robust application. I'd like to introduce Steve Sullivan, who works at IHG, to talk about a more robust application that he's developed using the Maps data API.
Hello, thank you. As you can imagine, this is right up my alley. I work for a hotel company, and we have 4,500 hotels to keep track of. And so keeping track of those is big business for us. So a little bit about my company. As I mentioned, we have around 4,500 hotels, and our most upscale brand is Intercontinental. There's one right next door to here. Some of you may have spent the night there or going to spend the night there tonight. We have Crown Plaza, Holiday Inn Express, Candlewood, Staybridge, and Indigo. So we get the advantages of the cloud that you would expect. Robustness, we get speed, reliability, all those things, and the heavy lifting is done by Google. So my company doesn't have to worry about setting up a database, opening up ports in the firewall, providing web services for our applications to access it. Essentially what we've done is we've gathered the data about our hotels, longitude, latitude, do they have a pool, do they have free breakfast, do they have free internet, those sorts of information that you might want to search on, and we've pushed all that information out to the cloud using what Tom showed us a little bit earlier. We push all that data out there, then we can write applications that search on that and display to our customers on different applications, like our Android app that will be launched in a couple weeks, our iPhone app, which is on the market now, doing really well, and also on our websites. So there's a couple screenshots coming up. But first, I just wanted to show, here's an example query that you can see, which it's very simple. That's part of the beauty here. One of the reasons I really like this is the query can be created past a longitude, latitude, radius, and a distance. We get back an XML. We can parse this XML and display it on a map. So if anybody goes to holidayinn.com or any of our other 7 brands, you'll see this technology being used today. Or if you have an iPhone app and you search find hotels near my current location, it's using this technology today. Here's a couple screenshots of the iPhone app, Android app and the iPhone app. So when we were developing our iPhone app, we ran into a situation where we realized the existing web services that we were using that were built for companies like Travelocity and Expedia, they didn't have all the information we needed. So the traditional route would have been, let's kick off a project and have our B2B team add those new pieces of information that we need. Somebody had an idea and said, why don't we use Google Maps Data API? And that was our first use of this technology. We had resolution to our problem within 24 hours. One of the developers stayed late, crunched some code, gathered our information up from our database, pushed it to the Google Data API. Our data's on that infrastructure. The next day we were searching on it and displaying on this map. So that's a great example of a traditional method which may have taken a long time, and we'd had to have made time for an existing team to put that into their schedule, and we were able to do it overnight and have fast, reliable service that you see. So that's it. Just one closing thought on this. It's really simple, and so that's one of the main features that I really like about it. It's you push your data, you query against it using REST queries or the Java API, which we're using, and your results are back in a flash, and it's reliable. We plan on continuing this. You're going to see more and more uses of this. We have all kinds of type of information we'd like to eventually push out, but for now, we're getting a lot of value out of it, and we're going to continue using it.
Thanks, Steve.
Sure.
And as I understand it, you also used the driving directions web service that we launched today.
That's correct.
Yeah. So the point is that I showed you the maps data mashed up with a V3 app. You can also use any of the Maps API family of services or other APIs and pull those things together. So once you do those, you can have geocoding, driving directions, elevation data we launched a couple months ago, and the Place API, which is coming out in June, which will be especially important for geolocation. So I'm kind of wrapping up here, but I also wanted to give you a little teaser. We'd, of course, like to have all of this stuff to you right now, but we do have it coming soon. You probably saw when I was doing that little JavaScript that I was parsing the KML. Now, parsing KML within JavaScript is not necessarily the most elegant experience. So we will be launching soon, by the end of Q2, by the end of June, a JSON feature upload and download. So there's no need to parse KML. Of course, if you have JSON being returned within a JavaScript application, it's pretty easy to parse. It's also very easy to parse in Python. You probably don't need to change it because you're using Java, and Java is pretty robust XML parsing built in. Yeah. Well, we'll have questions at the end, sorry, because I'm almost done. And then what we also wanted to announce is the Maps Data API is a great, simple API for providing spatial data. But if you have a ton of data that you want to do like heat maps for, if you're familiar with Fusion tables, we are proud to announce that we're going to be supporting Fusion tables in the JavaScript API natively. And what that basically is going to do is you're going to be able to have columns and perform SQL queries. So it's somewhat similar to what we've done in the Maps Data API. The Maps Data API would be focused on attribute searches and spatial searches. This would be an example of just selecting selecting your raw data and putting up a heat map, for example. So I will go to the live blogging reminder, and I will encourage you to ask questions. Let me bring that up and refresh. So you asked about JSON-C. So I have the lead engineer here, and I'd like to talk for a bit.
Okay, can everybody hear me? Well, JSON-C is a sort of a flattened form of JSON that's sort of easier to digest if you have very structured data. And if you looked at the KML spec, but it's got a lot of deep structure. So you've got like, place mark, point, blah, blah, or polygon, line string style. Anyway, so JSON-C lets you have a bidirectional, not necessarily lossless translation between XML, the DOM structure, and JSON. So you can have something that's fairly flat and very easy to digest and to manipulate in your program. And you can always say just output equals JSON and get a exact JSON representation of the XML. But it'll be ugly and it'll have the namespaces and blah. And we're very close to launching the JSON-C, which is much cleaner and easier to use.
It's still a object, literal.
Yes.
Yes.
Yes. Yes.
Yeah.
And then it's easy for the JavaScript engine.
Oh yes. Yes.
Yep. It's
That's the whole idea. Yes. Very much so.
So you asked whether it would still be accessible via objects in JavaScript. Right. Yes, they are.
So
like
the coordinates in KML, it's coordinates are a bunch of space separated, comma separated numbers.
Basically, you're converting the KML to JSON.
Right.
So there are
Both ways.
Yes.
that's part of the API to convert from.
If you want to use it that way,
Right.
yeah, you can use it as a KML to JSON
Right.
conversion,
You
vice
can.
versa.
Yeah. It's bidirectional.
Okay. I want to get to a couple other questions. What is the plan to offer other sort by options? Only distance sorting appears possible. For example, what if I wanted to sort by time or coffee rating? I know that we've tossed around some ideas for other sorting options, but Bart, if you could again address this. Why don't you come up here too? Because you're probably going to get most of these.
The answer for different sorting options is real soon now.
That would include multi-attribute search and stuff like that.
Right.
Yes.
Right. and numeric properties, and
Yeah, and it would be, of course, good to sort on your arbitrary data, because that's what you want to do.
Right.
Will Google Map Cloud Services support Open Geospatial Consortium standard APIs like WMS, WFMS, WFST, et cetera, in the future? I'm not actually aware of those. I mean, obviously we use Atom, which is
right. Atom and KML,
and
and KML is acquiring other standards.
Yeah, I mean,
GPX
KML is our
GX.
data format,
Right, I mean,
for the Maps Data API.
They're all, well, I shouldn't say they're all interchangeable. There's some things you can do with these others, but right now we're focusing on KML.
Yeah. Now, of course, if there's demand, let us know.
Right,
We're not
if you look at the KML reference, you'll see a few extensions to do with tours and so on, and we need to have a good answer for GPX data. The great thing about standards is having so many to choose from.
Yes. A question from the audience.
I don't see any documentation on the developer guide about search for Java. Is that implemented in the library?
For Java?
Sorry. Yeah.
I'm not aware of that, but we can certainly look into that.
So I mean, you get there's the example of the HTTP protocol provides search, right?
Right.
Yes. Yeah.
Does the Java library provide that?
There are similar functions in Java.
It's just a URL. I mean, there's no like structured construction of a search query.
There is a Java library to
construct search queries?
Well, I'm just in general for accessing the data API. Right?
Yeah. It's just a feed. I mean,
right.
you can get the /snippet feed, or
right.
you can get the /full projection and get like everything
right.
with all the features.
Yeah. I mean, the key point is remember that it's a feature feed, and the query is actually just extra parameters on top of that feature feed.
Right.
So you can just do those arbitrarily.
Right.
Yes.
I just had a question about. It looks a little bit like Bigtable. Is it being stored there, or is it separate?
Is the data stored in Bigtable?
Yeah. Well,
I don't know.
you don't have to say that.
I don't know, and if I did, I couldn't tell you.
Well, that's all right. But I guess my
I could
question
tell you,
is,
but I'd have to kill myself.
Yeah.
what's the advantage of using the API versus like Bigtable? Because Bigtable, you could do all those searches for the different attributes. So, is there a speed, or is there some sort of performance? That
Searches are blindingly fast. Can we talk about layers?
What layers? We've done about fusion table layers.
No.
Yeah,
embedded
we have a V3 KML layer object that you can provide a public URL, and it will render those KML. It renders them as an MVC object, so that means that if you it will only pull those features in that are in your viewport. As you move around, it will load those in dynamically, and that is very fast. Right. So that's an option for getting your data very quickly.
Right. Yeah.
Okay. Thank you.
Okay.
Sorry.
Any other questions?
The fusion tables, I was playing around with that a little bit. Is there an overlap between fusion tables and this Maps Data API? When should I use one? When should I use the other?
I would say, obviously, if you're doing a spatial search, if you're also trying to get something up to speed very quickly, Maps Data API is where you would go. Fusion tables was originally designed to have large columns of data sets. For example, to find the millimeters of rainfall in Brazil and do it by location, and then you could just have a huge column of that. It's obviously there's some things you can do with both. Fusion tables have heat maps, which the Map Data API doesn't. So if you want to provide some sort of heat map that basically shows denser populations, you definitely would want to go to Fusion tables. And if you want to do search, you'd want to go to the Maps Data API.
So I can leverage fusion tables to show a heat map on my Google Maps V3 webpage.
Yes.
I don't have to get a separate utility library or something like that.
Nope. It will be native.
Oh, okay.
Basically, it's a URL with a query, SQL query, and boom, it's there. I don't know what Fusion Tables has for an API yet. They may not have a.
They do have a public API.
Okay.
And because it's MVC, I'm not sure, but I would think that you could modify the query, for example, and it will update with in V3, it's
Right.
MVC, meaning model view controller.
Right.
You can update the query and it would update the data that's shown, which is, of course is pretty powerful.
Right.
All right.
Yeah, obviously, there's a lot of overlap, and right.
Okay, well, it's the end of the day. Thank you for attending my talk and staying up and enjoy the party tonight. Take care.